We are open whenever you want to go ahead.
Okay, let's get started with our discussion today. Thanks for all of you for coming. Welcome to November. It's the Russians' greatest general, what they say, right? Nobody beats General November. And I guess that's true partly in our part of the woods too, but a mild start to November for us. Not a record mild, but relatively mild. But we've got some things to talk about over the last week or so. Let's just concentrate on that. There's been so much going on over the whole Northern Hemisphere. First, locally, on Tuesday, was it Tuesday? It was the 29th. We got to 82 degrees. It's only the second time ever we were at 80 or above in Madison's recorded history. So the only other time was October 29th, 1937. And exact same temperature. So we tied the daily record for that day. The closest competitor for late in the year to get 80 was October 26th. So you know, it doesn't sound like much, but when you think about 150-ish years of climate data, and you're 3 days out past every other comer in the contest, that's pretty remarkable. So we did it again on Tuesday. And that was followed by a day where we crept close to 80 on Wednesday. Boy, if timing had been just a little bit different, if the whole weather system to our west had been maybe delayed by 6 or so hours, gave us an early afternoon and maybe late morning, early afternoon sunshine, we may have challenged again for 80. Would have been the latest date ever. As it was, what transpired the rest of the day, Wednesday and into Thursday, was remarkable in its own right. And I'll tell you about that in just a minute. Well, actually, I want to do that first, Pete, before we look at the current weather. So can we go, we'll take this off. Let's go to the climate page from the Weather Service. This is Madison's month of October. So I wrote it down here. I think I got the numbers down somewhere. We had 22 out of 31 days in October with 0 precipitation, so not even a trace. That's remarkable. We had 3 traces and 2.01 inches. So add them up all together, that's 27 out of the 31 days where we had almost no precipitation, okay? And we were way below average. We were only at I got it written down here, we're only at 0.34 for the whole month on October 28th, or on October 29th. Then we had our 2.21 inch or 2.49 inch deluge on the last 2 days of the month. That got us over the average. You can see if we go down a little bit more, Pete, our total for the month was 2.83, average is 2.77. So these kind of things, viewed from a distance, let's say we're 60 to 75 years away or something, you look at that quickly and you say, oh, this was like a normal month of October. It was not a normal month of October. And the month of September was the same way. I won't spend the time to go back, but we had one day in September, we had 3.97 inches of rain. That was the record on the 22nd. Had we not had that, we would have been about 1.2 inches for the month, which would have been well below normal. As it was, September was above normal. But you can see that these kinds of normals are punctuated by these extreme events. This one immediately following our record high 82 on the 24th. And look at 75, like 5 degrees shy. But pretty interesting. So there's always granular detail to be pulled out of these records, whether for the month or for the day. And that was really quite an amazing turn of events to have 27 days in the entire month of 31 days where we had 0.01 or less. And then suddenly we're average. Just incredible. So that was interesting for us. I think we also set the all-time overnight high minimum on the 24th. So it got only down to 65. And that doesn't show up on here as a record, but it is a record as far as I understand. May have also been a record for the day on the 30th of October at 64. And then you can see that Halloween day, that was the high temperature. That mid-12:01 a.m. was the high temperature. So it got cooler as the day went on. And we'll talk a little bit about that when we go further afield. But before we talk about the current weather, I want to also draw our attention to what happened in Spain this week. The same day on the 29th of October, there was an extraordinary rain event in Valencia, sort of central, western, eastern Spain, just to the west of the Balearic Islands, which are offshore. I think there were places in and around Valencia that had as much rain in 8 hours as they'd had in 20 preceding months. So the infrastructure built for those kinds of situations, prolonged, relatively dry periods, although that was an unusually small amount over the last 20 months. is just not ready for the deluge that they received on Tuesday and Wednesday. And let's go now to Alicia Bentley's maps here, and I think I've got it set up. I don't have it set up for the right area. Yes, I do. This is for the North Atlantic. So let's take a look at, this is 19 October. We'll just go ahead to about the 28th of October. And I think you just got to click the arrows to do that. Yeah, this will be the best. This is that mean sea level pressure is black, and then 250 millibar winds are in the shading, and then you have thickness from 1,000 to 500 millibars in red or blue. When it gets to blue, it's 540 decameters or lower, and everything else is higher. So this is a whole week before the event. Let's keep going ahead, Pete. An extremely wavy flow over the North Atlantic, I think, preceded this. You can see a number of waves and a couple of cutoffs. This one southwest of Ireland, that's on the 24th. And that one kind of heads into the Irish Sea and then up toward Liverpool. And then we're moving ahead. We'll get to the next wave that's going to break off out of all this structure. We can keep going.
That's as far as that one goes. That's
Oh,
the
so
middle
we just
mile
got to
wind.
get another bottle run. Sorry. Because we can always go backwards. Let's go to like the 26th, that's fine, yeah. Then we can keep going. Sorry, I hadn't set it up quite right.
Yes, we had no idea.
Yeah,
So
this
we're
is
gonna go
already
back.
too far ahead, so.
So we'll go like 00 to 26.
Yeah, and we just click back to the right day. Okay, so here we are on, that's the feature that's about to enter the Irish Sea. We can keep going forward. So watch, there's gonna be yet another, we'll just keep looking. There's another sort of wave that's gonna break over and then cut off over Gibraltar. That's this one. So it's 28th of October. And at sea level, black lines are sea level pressure. You don't really see any really strong low-level surface manifestation of this. This is over Morocco and Algeria. Atlas Mountains are right here. And so we have a decent region of low pressure for that latitude. It's 1,008-ish on the border of Algeria and Morocco. And but cold air aloft. You can see the cutoff cold air aloft in the thickness lines just over the Strait of Gibraltar. And that, let's go to the 29th, keep going ahead, I think it's every 6 hours. So it's not so well organized at the surface. This is now 0Z on the 29th, keep on going. Pretty strong cutoff upper low, one imagines, we'll see in a minute that that's in fact true, and then reasonably strong wind maximum at 250 to the south, and in Valencia is right about there, it's almost on the meridian, and that's where they got heavy rain. So you've got a couple of different things that can figure in here. First, the Mediterranean Sea is way warmer this year than it's ever been. This is the warmest year ever. In fact, I think they announced that on the 15th of August. But how do you actually take the average sea surface temperature of the Mediterranean? It's really interesting. And I couldn't find any regional breakdown, but it was 4 degrees above normal, which beat last year's record, which had been the prior record. But the seas right off of Valencia and the Balearic Islands were 2 or 3 degrees C warmer than normal at the end of the summertime. So that's one thing. The whole Mediterranean Sea is warmer than normal, a nice source of water vapor. Then you've got high elevation over northern Africa in both Algeria and Morocco, and that provides an elevated mixed level. So this is one spot that's a small scale version of what we get here in the central United States, especially the southern plains. The proximity of really warm water to high elevation where you can cook an elevated layer of almost adiabatic lapse rate. And when you put the two together, you can get some really wild weather in eastern Spain and southern France. This is a time of year where this is not at all uncommon for them to see, a fairly heavy rain event. But this one here was off the charts. And probably a function of the water vapor content of the air that is a function of the warm Mediterranean. And the Atlas Mountains don't get any warmer than they used to. That's not going to change. But the low level moisture is a big factor in that. And so let's, as you know, I looked at this morning, I thought, this is kind of a weak little cycle. So let's see what it looks like at another level. Let's go to the variables up in the top left there, Pete. And I think one thing that's kind of interesting to look at is, let's go to, 850 millibars first. And I think it also gives us the geopotential height. So this is at the same time, 12Z. And you can see it's a little more impressive as a minimum in, geopotential or sea level pressure is what you saw before. And so it's a little more impressive, but it's still in the same place, right at the Strait of Gibraltar. And theta E, high theta E wrapping all the way around from, almost the southern part of right on the border of the Sahara with tropical equatorial Africa. So one gets the impression that that's a viable moisture source. How the moisture survives in the air over this long distance is a reasonable question. But right into this portion of the bight of the east coast of Spain is where it ends up, and so pretty impressive. Let's take a look at There's another one too. There's a whole bunch of them. See here. How about the IVT, Integrated Vapor Transport in 700 millibar geopotential, same time? A more impressive cutoff. See how it's getting more and more impressive with increasing height. And look at the IVT. This is all above. The lightest color is 250, and the units are kilograms per meter per second. And so one does get the impression that there's a moisture source well outside of the Mediterranean that may well have fueled this big bullseye right there on the east coast of Spain at this time. And the circulation gets more and more intense with increasing height. Let's see what it looks like at 500 millibars. And there's a whole bunch on here, isotherms, and blue is the vertical motion. But again, the geopotential height in black, it is more and more intense in the circulation the higher up one goes. And it's sitting right over the Strait of Gibraltar. All the ascent, even though it's really ugly, too bad it can't be smoothed a little, it's all in the right place, downstream of the upper vorticity maxima. And the east coast of Spain is part of that location. I think it rained also in northern Tunisia and probably also parts of Morocco in fairly impressive ways. And then one other thing I wanted to show you, Pete, is if we look at the Cape, which is down there, lots of Cape over the western Mediterranean. So that's probably a function of the elevated mixed layer coming over the really warm, moist boundary layer that's there because of the unusually warm Mediterranean. So this is a perfect setup. And then here you're looking also at 850 millibar heights and temperatures. So you get an idea that there's really a pretty intense frontal type boundary here across Northwest Africa, and then flow around the thing is kind of coming right up to the right spot in Spain. And at the last moment, the air is poorly stratified and it's going to be easily lifted. So they really had a really intense couple of ingredients for this setup. I had one more thing, I think, on this list I wanted to show you that is interesting. Let's see if I can remember what it is.
Yeah, that was one of the.
Yeah, we saw that first. Maybe I've exhausted it. Look right here, we'll look at the dynamic tropopause. And you can see, the only thing I'll point out here, on your own time it might be interesting to watch the evolution. In fact, let's click back a couple of times here, Pete. And these are every 6 hours, we're going backwards. And so watch what happens. In the long run, keep going, one more, two more. Okay, so there's this filament of high potential vorticity. That's the equivalent of a fairly narrow trough. Okay, so here's the ridge upstream, the trophiness, and then another ridge. Our Central European colleagues often talk about these as PV streamers, and they have a lot of influence on summertime warm season precipitation in Central Europe, especially Switzerland, which is like an accordion of mountains. It's just like Nevada. I mean, when these things come across, they can really drop heavy precipitation in Central Europe. But what happens in this case is this ridge breaks off, kind of breaks into it, over itself, so it's a breaking wave. This is evidence of how wavy the flow was over the Atlantic region in the week preceding this event. And then it's going to cut off this little piece of the high PV air. And so let's watch that. We'll click forward. You can see it getting thinner and thinner. The little umbilical cord gets thinner, and this thing breaks off. And there it migrates a little further south, and then sets up camp. It kind of changes shape over the next couple of days here. It'll kind of consolidate in the southern portion, sets up camp right over the Straits of Gibraltar. And then it just sits there. It's a cold upper low. Okay, and it sits there and it rains like crazy. This is into the 29th when the event occurred. These things are known by the Spanish Meteorological Service as DANA, so Depresión Aislada en Niveles Altos. And that is exact translation for cut off upper level low. That's exactly what it is. Okay, isolated depression at high altitude. And so that's what it is. It's a cut off low, and a characteristic of this time of year, presumably, it's my guess, because anticyclonic wave breaks. Right? This is the big ridge breaking over itself are not uncommon here at this time of year. Partly fueled by tropical activity in the Atlantic, probably also a background climatology that favors them. And Sarah would know more about that. I don't particularly know that much about that. But the tropical cyclone influence does not appear to have been a major piece of this one, and so that makes me think there's just a background climo as well that can be exacerbated by the presence and active nature of tropical cyclones. But the result is right along the meridian, when these waves break, you cut off these little pieces of PV, and depending on exactly where they end up, it's a flood in Spain, it's a flood in northern Italy, it's a flood in southern France. And so this one was devastating And again, exacerbated by the unusually warm Mediterranean, which makes the Cape even stronger in that western part of the Mediterranean basin. So that also happened this week. What a week, okay? And there's plenty more to think about on this thing. Then, look at this story, right up there, Pete. For the first time in at least 130 years, Mount Fuji gets through October with no snow on its top. This hasn't happened at least since 1894, maybe earlier than that. This is a little bit earlier than the current time, but the picture would look the same today if it were clear. So there's no snow on the top of Mount Fuji. And that is rare for the end of October. It hasn't happened since 1894. So that's pretty neat. Let's look at the hemispheric cold pool. Maybe it's that one? Put it up here. No? There it is, yeah. So here we are all the way through October 31. See these little yellow dots? They just indicate days on which this year has set an all-time minimum value for the 850 minus 5 horizontal aerial extent. So we've gone through 61 days in this time series, September 1 to October 31st. 6 of those days have set an all-time record. So 10% of the days ticking by this year have been all-time minimums for this particular measure. And we're right about at the average here as we end October. That's the first time we've been close to it for a while. It's the 3rd warmest year out of the last 77 to this point in the season. So the hemisphere is taking a long time to cool down. And it's probably, well, I think that's certainly the long-term trend there is that it's a function of the global climate change and atmospheric composition change. But then there's vicissitudes in individual years. Why do you get a depression here around October and then you kind of climb back? These things are related to large-scale circulation in ways that are still mysterious to me. But this is part of the broad-scale background condition that led to a snowless Mount Fuji for the first time in 130 years. So the whole hemisphere has been unusually warm, and that's been a dramatic thing to keep track of. Of course, I don't have to tell this audience that I like records. I don't want to finish 3rd. You know, that's what we did in the National League. That wasn't as fun as finishing 1st. And hopefully, we'll see ourselves well below this for some of the rest of this lead up to the deep part of winter. If we don't, I can live with 3rd warmest for the first 2 months of the fall. That would be pretty good. So, okay. And then last night it was windy, and I wanted to kind of suggest to you something about that. We can maybe go to Alicia's maps again, Pete. We'll just change the region to CONUS. That'll work. And then we'll go back to sea level pressure. That'll be good enough. And let's move to, so this is actually a good place to start because it'll give us a background for the weather that we experienced after we got past our record warm day. So that was happening right around this time. So if we step forward a little bit, you can see this cyclone that's kind of stretched out along the baroclinic zone. The 1,500 thickness contours are tightly packed here, and that's no surprise. The jet is there as well at 250. That's what's shaded. But it really is difficult for a cyclone to spin up when you have this kind of strong stretching along the jet. And that's a really good example of that. There is a minimum in sea level pressure, but it stretches from Isle Royale all the way down to the Panhandle of Oklahoma. And that's not a very intense one. It's only 1,004 millibars. So let's step forward a little bit, and you'll start to see something emerge from the southwest. And this is now Halloween Day. It's getting a little bit better organized over Iowa at 0Z on Thursday night, or on Wednesday night, and then pretty intense midday yesterday, right? And so you get but even so, only 1,004 millibars. But the big change is the pressure gradient has changed its orientation. It was originally just along a strip like this that was a strong pressure gradient force. Now you start to see something in central northern Iowa by yesterday morning. Fairly weak over us, although it was still windy overnight. Now if we click ahead 6 more hours, then we're looking at that strong pressure gradient force kind of right over us. And that came along with some pretty heavy winds, and it would get even stronger over this region. So, but still, no substantial sea level pressure development. So a person might be confused and say, well, how can you get a big pressure gradient force and therefore strong winds when you don't really have much development going on? It's easy to pay attention just to the central pressure instead of the orientation. And let's look at this particular time, what kind of vertical motion, at least at 700 millibars we had, and that we can get from my omega charts right here, Pete. And let's go to, I think it'll be 18 hours from yesterday. See if we get the right time. Yeah, this is 18Z. Well, this is 18Z today. Sorry, we can't do that. Let's go back. if we go, scroll up, I don't think that, this way, I mean, to get further down the page. I think the 12Z hasn't come in for today. If I'm wrong, this will not quite work. So, yeah, let's do a 6-hour forecast. If this was made yesterday and had not been updated, rats. Curse efficiency. I don't have it available, sorry. But I can tell you what it looked like. We had a couplet of strong ascent just down shear of the cyclone, strong descent just up shear of it. And the couplet of strong ascent, strong descent is, I think, what reorients the pressure gradient force and puts us in a position to experience a really strong southerly wind that we had yesterday. So it's not necessarily the development only, it's just the way that things are all configured that can give you that strong pressure gradient force that's requisite for driving the strong winds. So sorry I didn't save that, I didn't have that ready. But that was certainly what was driving that. Now, if we can march forward, let's go back to Alicia's map. This will get us to the current weather. So this is yesterday afternoon, just another 6-hour click. And then this thing starts to move out. It doesn't get any deeper, 1,004, but it starts to move out. It was windy through the night. This is 7 p.m. Let's go again. Then look at what happens to the sea level pressure movement. It gets stretched again. So it's weakening again, based really much on its geometry. It never gets below 1,004. One more time, Pete. Now you can see 1,004 is barely still visible over maritime Canada and parts of Maine. And so our pressure gradient force is weakened with the progression away of this system. And so this thing never really got organized. There was a period where there was a little bit of development, and it would have been nicely reflected on the vertical motion shots if I'd saved them, where the ascent-descent couplet was strong, and then by this time, it's weakened out to almost nothing, at least at one mid-tropospheric level. So the whole thing kind of decays away. And so that leads us to the large-scale picture for the current weather. Can we go to the satellite movie first? You can kind of see, here's the central, perhaps central part of the circulation. Yesterday's satellite picture, which I think we won't have time to show now, looked a lot more impressive over Minnesota and Wisconsin. This thing's just been kind of stretched and sheared out of existence, and it's getting weaker and weaker as it goes. That doesn't mean it can't still have sensible weather associated with it. We'll see on the radar in a minute. Much of that might be offshore, but it had rained nicely over central parts of New England and the middle Atlantic states, and there may still be ongoing precipitation down over the southern states. Then when across the rest of the continental United States, it's fairly clear, a little bit of something here in the Dakotas and western Minnesota. We'll see offshore in a minute that there's a pretty impressive cyclone out there in the Pacific, especially over the Aleutians. So let's go to the radar, if we could, Pete.
John, I want to give a quick shout out to
Oh, yeah.
Sun Prairie East High School Weather and Climate classes joining us virtually today. So
Hey, all right,
welcome.
great. Good day for that, too,
Yeah.
so there's a lot to talk about. Yeah, so there's a little bit of precipitation tied to this cyclonic type feature on the border of the Dakotas, which is interesting. There's some also over the Pacific Northwest. We'll pay some attention to that. And you can see we're getting just a little bit of echo, especially when it goes offshore, it kind of disappears. But so you imagine this is kind of lighter precipitation associated with the storm that's now, that had visited us yesterday and is now making its way into Quebec. And then some convective type precipitation that doesn't seem to be moving in association with the progression of that system, both over the Dallas area, then over the coast, and a little bit in the vicinity of New Orleans. So that's about it around the country today. A pretty nice day, by and large. Okay, let's take a look at the West Coast satellite image, Pete, if we could. Yeah, so here's the big beast that has been spinning around off the Aleutian Island chain, and that has a really strong omega couplet associated with it. Big cloud mass. There's another one that's forming deep in the cold air behind the main cold front. You can see the open cellular convection back here. That's a clear sign of really cold air aloft over a relatively cold ocean, but it's cold enough aloft to make the lapse rates just about, if not just moist neutral, better than that, probably moist unstable. And this thing just gets going with the slightest impetus aloft from some little vortex at upper levels, and that's a storm that's kind of got a nice little small scale structure that mirrors the big, larger one to its north and east, but it will suffer the same fate. This one's going to get sheared away, and it turns out so will that one. And that's it. And then there's a feature that's crashing into the Oregon-California coast, kind of got an odd orientation. It's coming in from the west-northwest, like Patrick's big storm from 2019. And we saw some of the precipitation that's in there as a result. And one last point, it's kind of a wavy ITCZ. I think you can see that. There's a little hump here and then another depression and then convective features along the way. Curious about that, but I don't know much about it, so I can't say more than that, although it's interesting to see that. Okay, let's take a look at a couple of upper level charts and then I'm going to turn it over to Patrick. Sorry I've taken so long, but there was a lot happening this week. Yeah, let's go to 500 first. The epitomis super-peats. As you know, this is from this morning at 7 a.m. So there's a really sharp little upper trough here, and that's the thing that's at least maintaining that circulation we saw in the satellite picture. Downstream of that is where there's cyclogenesis. Look at how flat and featureless the flow is across all the rest of the country, with a slight southwest to northeast tilt to it. And then off the coast of the northwest, some pretty sharp contrasts in the upper level cutoff here, but there's a couple of little waves. This one here, I think, is responsible for the feature we saw coming onshore on the west coast. And then closer to the Aleutians, that's the upper feature tied to the fairly big disturbance. We don't see far enough west to catch the next comet that's in the cold air, but it would look probably more like this, I think, than it does like that. Not as well developed, not as high amplitude. And this is relatively warm air for this time of year. When November 1st to be minus 16 only at Green Bay is, I think, unusually warm. And perhaps not surprisingly, this is where the main belt of the westerlies are on this day, which is barely looking autumnal. And we're only a month away from December 1st. So this is in no cold air reservoir to speak of, except way up in the archipelago. The whole part of most of Canada, continental Canada here, is warm. Minus 21 at Winnipeg, that's ridiculous, okay, for this time of year. So pretty amazing. Probably means we'll see that 850 millibar cold pool area not really skyrocket. It's going to get smaller again, or at least stay below the average. Let's see what it looks like at 300 millibars peak. Yeah, and look at how weak the flow is at the jet level. And this is where it ought to be the strongest, of course, right where we have the southern extent of the strongest winds. But there's not really much 500 millibar baroclinicity. I think 1,500 thickness would be weak too, so the wind speed can't increase very much. Back here, where we have a really strong upper wave and strong thermal features, that's a stronger jet. And then this is the northwesterly jet that I think is carrying that feature in from that funny northwest type orientation. Here's a subtropical jet core, I think, that's kind of in proximity to the vestige of the polar jet here over eastern maritime Canada. But by and large, the wind speeds are pretty weak in this part of the western hemisphere, even as far north as the archipelago in Canada. And that's reflective of the lack of a strong temperature contrast temporarily in that location. So, I mean, that preserves us from from the specter of getting really cold in the next few days, because that's where the air comes from to make us cold, and it isn't there right now. So it's got to first be imported there or created there. Either way, it takes a few days to do that. So we get probably through at least middle part of next week without any threat at all of any cold air incursions into the U.S. And then one last thing, let's look at 850 millibars, Pete, and then it'll give us a view of maybe the thermal structure of that feature in the Pacific Northwest. So look at this intense baroclinic zone. That's every 5 degrees, these dashed red lines. So that's 10 degrees right there. An extraordinary minimum in geopotential height at 850. It's only 960 meters above you if you're out on, whatever that UTAC or whatever that island is in the Aleutian chain before you get to 850. So the pressure is really low. And then there's intense, like localized, intense baroclinicity right along this warm frontal structure. And then a nice thermal ridge that gets right back into the cyclone. And that accounts for a lot of the cloud and precipitation, although we can't see it on the radar, a lot of the cloud and precipitation features that are likely associated with that storm. And here's the strong baroclinicity that is characterizing the entire evolution of this weather feature that we experienced. We were on the warm side early in the week. We're now on the cold side of it. And I think most of the activity that has to do with precipitation or cloudiness is forced by frontogenesis, not by cyclogenesis. And that's the characteristic of situations in which the flow on the warm side is parallel to the isotherms, no temperature advection. On the cold side, it's only weakly cold advection, but the differential between cold advection and zero means the gradient's getting stronger. The response is a thermally direct circulation, and we're seeing that manifest in the clouds. And we saw it more vividly a day or two ago manifest in ascent combined with weak stability to really give us heavy precipitation. So a lot of things are getting nicely set up and developed here at the beginning of the cold season, even though it's not particularly cold. So that's all I have. Sorry I took a little longer than I intended, but Patrick, if you'd like to say something about the forecast, that would be great. Thanks.
Okay, so what I want to talk about and what I'll show is these two features, the one off Alaska and then the one off the Pacific Northwest. Those are going to be our weather makers coming up, and it's the combination of both of them, not just one of them. But first, can we go back to the current satellite, please? This was one of my talking points. I did point it out when Professor Martin was presenting, but do you see this band of clouds, or it looks like clouds that's not moving in Minnesota? That's snow. So they got a pretty impressive snowfall event. Places in northwestern Iowa went from 82 on whatever day it was, the 29th, to snow on the morning of the 30th. And it dropped, 4 to 6 inches of snow, a nice snow band all through Minnesota. That's still visible today. And if we go to the weather.gov, we can see the snowfall reports, because I think it's a pretty impressive snowstorm when you consider how warm it's been. So I think if we just click near Duluth and scroll down, maybe, here we go, yeah. Weather storm here. And Halloween snowfall events. So there we go, here's your snowfall. Some locations, the yellow is 6 inches or more. So a long region of 4 to 6 inches, and this extends all the way down to the southwest corner of Minnesota. Places in our state, also I think these are in Wisconsin, if my geography is correct.
Yeah, that's right. Lady
So,
Smith,
yeah.
Rice Lake.
So 6 to 8 inches of snow. For these places, we were not the beneficiaries of the snow, unfortunately, but that system, you can imagine, it was very strong winds, as was shown. It was snowing pretty heavily, and the temperatures were above freezing this entire time.
Oh,
So I can imagine you still might have some leaves on the trees. This probably took down a decent amount of trees in this portion, especially in the UP, where heavily forested regions. So I would imagine we'll see reports of that going forward, but this just happened yesterday, so we probably don't have reports of that yet. But nice snowfall for this region, and I'll touch on, we might have another potential snowmaker going forward here as well. But if we go back a click to just weather.gov main page, one more please. And then if we scroll down, and keep going, we'll go to the current outlook maps there. So we had rainfall, 1 day of rainfall in October pretty much. Let's see if it's gonna rain more. If we go to QPF, and I'll just focus on these total day 1 through whatever. So we'll first start there. This is total rainfall in liquid precipitation, so it's not accounting for snow or ice or anything, but it's valid from tonight into Monday. And you'll see there's a nice band of precipitation that sets up across the central part of the country, also in the Pacific Northwest, and this even stretches into our region. So we're in the 1 to 2 inch range of liquid precip up until Monday. We go to day 1 through 3, you'll see it increases. Same exact regions. This is now 5 to 7 inches of rain in Oklahoma. We increase now to day 1 through 5. Now we are in the fun. This is 3 to 5 inches of rain for our region. If we keep going, day 1 through 7. This is now valid all the way till Friday, next Friday morning. You'll see we get between 4 to 6 inches of rain forecast in a large region that is forecasted. The yellows here, that little yellow pixel, 15 inches or more forecast in Oklahoma. This is important. We know we haven't gotten a lot of rain. Portions of the central country also have not gotten a lot of rain. So seeing this is a good sign. It's good to have rain, obviously. But for the drought conditions that's been plaguing most of the central part of the country, seeing a large band of heavy precipitation is good. The amounts might not exactly verify, but the signal is there that we might see a lot of precip. And you'll see that if you go forward in the forecast, especially over our region. And so I'll talk about why this is, rain is predicted from the systems that are out over the Pacific.
Nice that it's coming down over several days too, and not all at once.
Yeah.
Exactly. Yeah, exactly. This is a drought buster. You're not going to have a drought buster when you get 3 inches in 1 day and then nothing for 30 days, because it all just runs off and doesn't soak in the soil. So exactly right. This is going to help with the drought over the central part of the country.
Looks
So-
like that might be the only spot over the 48 where the weather might impact the turnout on Tuesday for voting, if people still
Exactly
have
right,
to go and do that.
yeah.
so.
And I'll show you, there's a system that's going to be centered over Wisconsin on Tuesday. So, but if we could go to our forecast maps, the GFS, and I'll start with the loop at 500. So we'll get a look at trough ridges, stuff like that. And I'll just step through the 500 completely first and then show you how it connects to the surface. So we could go to the loop. And we'll stop it, and can we start tonight at 0Z? So 12 hours into the forecast here. So you'll see sort of the same features that were set up. We have one trough, maybe it has two little short waves, but general troughiness over the northwest. Here's the remnants of the system over Alaska, and then that polar low that was pointed out in its wake. But you can see they're both oriented, in relative proximity. This one being the weather maker for the United States and the lower 48 at this time. Otherwise, pretty much zonal flow. You would have warming in the lee side of the Rockies, which I'll point out. But this is going to be one component of our weather going forward. So if we could step to like 36 hours in the forecast, we'll watch this evolution here. So you'll see it generally hangs out over the northwest. It digs a little deeper. If we go back, I think one click actually. Yeah, there we go. So you see it develops, sets up over the Pacific Northwest, but the vorticity weakens. It becomes stretched out. You don't have a nice gradient geopotential, relatively weak winds, but the feature over Alaska is going to provide a little like boost of energy in terms of vorticity, and you can see how tightly packed the geopotential heightlines, and then the winds are really strong. This pendant of vorticity, this little wave in the large trough ridge pattern, is going to provide forcing for development further for this trough. So if we keep going forward, let's go to like hour 54, and we'll watch, here's that pendant. It keeps coming down, perfect. So now it's made its way all the way down to the desert southwest. You can see now we have a more well-defined trough with a nice vortex structure on both sides, particularly on its upstream side. We have a complete dominance of this trough now over the entire western part of the United States. We have an upstream ridge, so you can imagine nice forcing for ascent as you go from sub to super geostrophic. This is right over our region. This is Sunday. We get a little blip of precipitation. You can see there's a little trough forecasted and associated vortex max as it's moving over our region Sunday, and we're expected to get a decent amount of precipitation for Sunday. That was the first little push of rain in the QPF, but we'll watch this on the upstream side of this trough. If we go forward to like 72 hours or something, watch it intensify as it moves. You get in the maximum in curvature. Now we have a really nice vortex structure. This trough has deepened. Now we have a almost a cutoff feature, even though it's still connected to the large-scale pattern. This trough extends from basically near the Arctic Circle all the way down into Mexico, and we are now, it's inching its way towards the east. So here's another wave, another feature. You can make out a little trough axis. This is Monday morning, another push of rain for us, but this is going to be the large weather maker as it keeps moving to the west, or to the east, excuse me. If we keep going to, let's just keep going. Look at it intensify. Now we have a really nice strip of vorticity. You can imagine, I'll show the thermal wind, but there's decent amount of advection of this vorticity by the thermal wind right over our region. This is Tuesday. We have a significant storm that's going to impact us. I'll show you on the surface.
Yeah, the conjunction of the negative vorticity to the east of the strip makes that's a squall line. This
Exactly
is going to be wild.
Exactly right. Yeah, if we could go back, I'll point that out. Here we go. So it's not the most friendly color shading, but this is negative vorticity. This is positive vorticity. You can see you go from negative to values that are like 50 versus, I don't know, -6 or something. So that's a lot of gradient in vorticity in a small area. This is probably indicative of thunderstorms in that region, and it persists if we go like 2 clicks forward. You'll see we have this negative vorticity. It moves over our region, so we might get more storms Monday night, which is good because we haven't had those in a very long time. And now you can see kind of a weird orientation of this trough. It's over much of the conus. Two nice vortex strips, particularly strong on the downstream side, and we are right in the region where you might expect some large-scale ascent. If we keep going forward now to like hour 104, I believe. There we go, and then takes on this really weird shape. We're still on the downstream side throughout the entire time, but the trough feature has largely fallen apart, and it becomes too really skinny. You don't have that nice gradient of vorticity anywhere as it's a long strip in nature, as opposed to, where you have a lot of vorticity going into no vorticity, strong gradient. But this will be our first weather maker, and if we keep going, we'll see a development of another trough feature, almost the exact same region, mechanisms for development. This sits over the western portion of the United States until it's dislodged. This is Friday, and now we get, and I'll show you this, a nice development over the Central Plains.
Very different.
Friday into Saturday, and so that's the next weather maker for that part of the country. But this one will be interesting, because you can see how nicely this is wrapped up. Nice vortex feature. This might be a significant snow event for the Central Plains. Earlier models had this configuration right over our region. We were getting snow from this event. This is just yesterday. Now today, this is completely shifted over the western portion of the United States. So there's still a lot of uncertainty where this is going to set up, but where it sets up, we'll probably get a heavy snowstorm. And this is next Saturday morning, 7 a.m. local time. So might have some interesting football games if you get dumped on a foot of snow overnight and then you have to play in that. And it's still snowing over you as you're playing, especially teams from out west might have trouble playing in that. So something to watch for sure.
Yeah.
And if we could go to the surface, I'll show the same sort of run through here, looking at the surface. And so let's see, this is perfect. So this is Sunday morning, 7 a.m. local time. We had that trough that was, oriented very weird, but here's a blip of precipitation. If we keep stepping forward, we'll watch it move over our region and up into Canada. Here's another one developing. This was the second little shortwave feature that develops. Nice bit of precipitation. We keep going. We'll see there's a development of a low pressure system.
Yeah.
This is Tuesday. Here's your squall line that we were pointing out.
Yeah.
Keep going. Nice nice strip of baroclinicity. Keep going to like 12Z. One more click. There we go. We have a nice development of a low pressure system over our region. This is Tuesday morning, so an important day to be standing outside. You can imagine pretty windy. It's raining, relatively cold. Not the best conditions, but still important to be out there and vote for sure. Keep going forward. We'll see that, trailing precipitation over our region. Rains for a couple days, Monday, Tuesday, Wednesday. Then we dry out. We have this high pressure system set up just to our east, and then we get into the warm air region, or warm air advection as we go forward into Thursday. You can see thicknesses increase, and here's that next trough feature. Bringing a lot of cold air based on the lower thicknesses. If we keep going to Friday and Saturday, we'll see all this cold air kind of gets trapped over the mountains, and keep going to Saturday. Here's development of a significant low pressure system. Now we're into, this is 1005, if we keep going to the 12 UTC Saturday, now we're near 1,000 millibars. All of this in the backside is snow, forecasted by the model. And maybe this shifts a little bit. We get in the warm sector precipitation, maybe it doesn't. Snow stays over the western portion of the United States, but this is something to watch. We'll definitely, this is Saturday, but this will be developing next Friday, so we'll definitely have to point this out for Weather Watch. So maybe there's another snowfall event, but it takes a week to happen. Otherwise, all the snow and cold air is going to be over the mountains as typical. We're going to stay relatively warm, but wet, which is good, because we haven't seen that in a while. So any questions or anything anyone wants to see?
What's going on in the Gulf?
I don't want to mention that, because last time I mentioned something, I said, oh, there's not going to be development. It was Hurricane Milton that went through. This is also the DFS, so
It's just 1 mile.
I don't know. I know, but I don't want to be very wrong again. Because I kind of put my head down and was like, oh shoot. That was not the best prediction. But luckily, what's shown here, this is maybe this is a hurricane. If we step back a couple clicks to where this is developing, it just kind of lingers. It's bad for Mexico, but not bad for the United States. And none of the models yet have this impacting the United States. So this sort of just hangs in the Gulf Coast, whatever it may be, if it even develops. Luckily, hopefully not impacting Florida, because they definitely could use a break.
Yeah, that's for sure.
And I think I saw this kind of just dies in the model over Gulf Coast. So anything else?
No.
All right.
Thank you,
All right,
Patrick.
next.
Thanks, Pete. It's getting interesting. One thing